So we are going to cross multiply all of our proportions, and we are going to figure out how this works. We're going to write it out as its products. So we have 6 times x, which is 6x. We have 5 times 8, which is 40. Now what are we going to do to solve this problem? Divide by 6. So x equals 40 divided by 6, or x equals what? What? 6.6 repeating. Now let's do our second one. So we have x times 9, which is what, class? 9x. Then we have 22.5 times 10, which is what, class? Move the decimal over one place. 225. Then we're going to divide by 9 on both sides, so the value of x equals what? 25. Jordan is not the only one that needs to answer these questions. Okay, this is where it gets interesting because we're adding that what? That fraction. I have a question for you. Can somebody please divide 1 by 4? So 1 divided by 4. 0.25. So I'm going to rewrite this problem as 11.25 over x because it looks a little less scary than the fraction that's sitting right there. And now I'm going to do what? Cross multiply. So 5 times x is 5x. Thank you, class. What's my next step? 8 times 11.4. I'm sorry. 8 times 11.25. What do you get? 90. Then we're going to do what? X equals 18. How are we doing so far? Okay, this is just cross multiplication. So in order to solve proportions with multiple variables, we now have to take a few steps. So do y'all see that we have multiple variables? We have an x on the left and we have an x on the right. Next week, after your benchmark, we will be starting to dig into, after your test that we're going to take, dig into solving equations. This is going to lead us into Module 4. We've been doing it on your fluency, solving equations. The next module is all about solving equations. It's by far probably one of my favorites. I absolutely love solving equations. I love figuring out what the value of x is because guess what? It just solves the problem. I'm a problem solver. I like puzzles. It's a puzzle that I can solve. So what we're going to do is we're going to start building that fluency, that understanding of solving equations. This is stuff that you have seen. You have seen stuff like this in 7th grade. You know how I know? I saw Mr. Davis's lesson plans yesterday of what they're learning. And guess what it is? Solving equations. So let's go through it. So in order to step 1, we need to write out our equation using cross, what? Multiplying. I'm going to put cross products just because it's the mathematical term. Next to it, I'm just going to write multiply. So let's do that first step. So the first step is going to write out our equation using cross product multiplication. So ready? I'm going to draw my little arrows. 4 times x is 4x. Then we have 7 times x plus 2. So how could we write that correctly? We could do that. Can we write it not simplified? So let's do this. Watch. 7 times x plus 2. That way our brain can see it. Jordan did it in her head. If you did it in your head, great job. But we need to look at it for what it is, and then we can simplify it. So then we get 4x equals, now we're going to use the distributive property. Remember? Ms. Goday calls them what? You remember? Arrows be popping. So the arrows be popping into the parentheses. So 7 times x is 7x. 7 times 2 is 14. Okay, so now we need to simplify each side. So we simplified one step, so simplified each side. Then we're going to do what? Something the variable. What do y'all think we need to do with that variable? What needs to happen to the variable? Does he need to have friends or he needs to be alone? He's alone. We need him all alone. We need to isolate that variable. So when we isolate the variable, that means that we need to get the variable all by himself. Well, we have a lot of things attached to that variable, but I have a question for you. When you have an equal sign right here, and there's a variable on the left and a variable on the right, plus there's a constant. That's what this 14 is. His name is Constant. He just kind of hangs out. He is constantly around, just hanging out. When we need to move and match, we need to get like terms alike. So what on the right side matches the left side? The what x? The 4x and 7x match, right? But there's something in between them. What's in between them? The equal sign. And if anything moves across the equal sign boundary, its sign changes. So what sign do we have in front of this 7? Positive or negative? Positive. You want to know how I know it's positive? There's nothing in front of it. If there's nothing in front of it, it has to be positive. If there is something in front of it, it's usually a negative sign. But sometimes it looks like a positive sign, so this is a positive 14, right? So if there's nothing there, though, it's usually a positive. So what's the opposite of positive? Negative. So we're going to subtract 7x from both sides. 4x minus 7x is what? Negative 3x's equals 14, because that constant just stayed over there by himself. But now, is my x by himself yet? No, he has a negative 3 attached to him. How is he attached to him? Multiplication. Because anytime you have a number next to a variable, it's the coefficient multiplied times that variable. I'm using big math words. This is what we're going to be talking about. I'm going to use a lot of words like variable and constant and coefficient and all of the things, and you are going to know exactly what we're doing. So that negative 3 is multiplying times that variable. So the opposite of multiplication is division. So we're going to divide both sides by a negative 3. Class, why do you think we have to do it to both sides? Why do you think we have to do it to both sides? Well, what do you think an equation is? What's that thing in the middle? It has to be equal on both sides. So my question is, if I have Amelie's Chromebook and my book on one side, am I even? What's happening? Besides the fact that Ms. Goday needs to work out. One side is heavier than the other. In order to make it so that it's unbalanced, right? So in order to make it balanced, am I balanced? Yes. Why? Because I have the same thing on both sides, right? I have a Chromebook which equals a Chromebook. Yes? It's okay if I drop my book because it wouldn't have been equal. I still would have been heavier on this side if I would have had my textbook there. Right? So the job of an equation is to say, okay, Chromebook equals Chromebook. Textbook equals textbook. The value of x equals 3. So that means that anywhere that there is an x, it's going to be what? Equal to? If I say x equals 3, that means the value of x equals what? Excuse me, a 3, right? So that means that anywhere that I have an x in my problem, if I plug in the value of 3, it's going to make my equation equal on both sides. That's the property. That's the whole purpose of it. So what is 14 divided by negative 3? Negative? 4.6. You're right. X equals negative 4.6. Repeating. With similar figures, you must set up a proportion in order to identify what? What's the kind of sides that we were talking about? For proportions. Corresponding sides. Okay, so in example 2, we have the similar triangles that are, the triangles shown are similar. We're determining the value of the variable. So we can color these and make them all pretty and figure out what matches what, or we can just simply set up what's happening. I'm going to just highlight these green just for the time being, because that's the only pen I have up here. Oh wait, I have a red one. Okay, so how do we set this up? Do you want big over small, small over big? Big over small. Okay, big. What's the big triangle's length? 20. Small triangle's length? A minus 8. Well, that looks fun. It's going to be fine. Same thing. We're setting it up the exact same way that we would normally set it up. We just have a variable in it. Okay, ready? So we did the big over the small. Now we need the big. What's our big for the other side? 8. Its corresponding side. 4. And now we're going to use what? Cross multiplication. So 20 times 4 equals 8 times A minus 8. What's 20 times 4, class? 80. And what's 8 times A? And what's 8 times negative 8? Good job. Okay, now we need to figure out how we're going to solve this. We need to get our variable all by himself. We need to isolate him. How are we going to do that? We're subtracting 64 from both sides? Why are we adding 64? Because we do the opposite operation. Opposite of subtraction is addition. Add 64. What is 80 plus 64? Good job. Now, is my A by himself? No. How do you undo multiplication? Division. 144 divided by 8. A equals 18. So ready? Watch. That means that this is 18 minus 8. So the value of this is what? I just plugged in the value of A. 18 minus 8. So the side length right here is 10. I substituted the value back into the problem and solved for the value that it was. Okay, ready? Let's set up a proportion for this one. So table 5, how can I set it up? Why 10 over 9? Are you doing small over big? Okay. X minus 3 over 10, are those corresponding sides?
No. X minus 3 over 9.
Okay, so this side right here corresponds with this side right here, correct? Yes? X minus 3 over 9 equals, then what? X over 10. Well, this looks exciting. Here we go. Cross multiply, we get 10 times x minus 3 equals 9 times x. I'm just multiplying it out. So what's 10 times x? What's 10 times negative 3? 9x. Okay, now what? How do I start solving this? Table 2, what would you do? Madison, what would you do? Are we at that part yet? Okay, so what matches what? We have variables on both sides, right? Okay, are variables supposed to be on both sides? They're supposed to just be on what? One side. So, which one do you want to move? You want to move the one that has the most attached to it. So, if you have a lot on this side and just a little on this side, take that 10x and move it over to the 9x. That way they can be friends. So, how would we move 10x? What? Say it again? I really just couldn't hear you. Okay, but what are we doing? What operation are we going to use? What operation are we using right now? What are we using? Addition. So right now there's a 10x and it's addition. What's the opposite of addition? So we're going to subtract 10x. So 10x minus 10x gives us 0, and we're left with negative 30 equals, what's 9x minus 10x? Negative value of x. Can we leave it as a negative x? No, you can't. It has to always be what? Positive. So how do you undo? What's attached to it? This is always fun. This is my favorite part of multiplication. What is x being multiplied to? A negative what? A negative 1. There's a negative sign in front of it, but there's an imaginary number 1 right there. Negative 1 times x gives us negative x. Right? So if we want to undo, we're undoing multiplication, so we're going to use undo multiplication is division. We're going to divide by negative 1. So the value of x equals what? What's negative 30 divided by negative 1? 30. So the value of this side is 30 and the value of this side is 27. We okay? Okay, turn the page over. Oh my Lanta! Not the word problems! Okay, so these are exactly what we did whenever we were using the pictures with Henry. So we have word problems. We're going to read through 2 of them, and then you are going to do the rest of them. After this, I'm going to give you an activity, and you are going to do a Mad Libs. It is on your computer. I'm going to give you the answer sheet, and that is what we're going to work on for the rest of class. If you finish it, you will do your tech work. Okay? Here we go. Which problems look the scariest that y'all want me to do with y'all? 4? 3? Which one? I don't have that one.
No.
Okay, 4. So, let's look at number 4. A surveying team. Why? Because it has a lake? There's a circle attached to the top triangle, so it's super scary? That's the scariest one y'all chose. Okay, got it. So, a surveying team needs to measure the distance across the lake. Across the lake. So look. Across the lake. This is what we're looking for. They make measurements shown along the ground. I'm guessing the triangles are the ground. So what is the distance across the lake? Well, here we go. What is my small... This was terrible.
Oh, I love your hair. Hold on. Just pause.
Here we go. So, we're figuring out the proportions. How did y'all set this up? Anybody want to share? Betica, what you got? Your hand went up first.
192 and 96 equal to x squared 40.
I have a question. So 192 only measures to here. Is that the full triangle? Did anybody else do that? Okay, so 192 isn't the full triangle. 192 is just that section right there. The rest of the triangle is this 96. So we'd have to add those two measurements together to get the full side length of that big triangle. Are y'all okay with that? Do y'all see what's happening? Yes or no?
I'll do that and we can just combine the two over 96. I put 208 over 1 4.
Well, you can't, and this is why. They're telling you that this length right here is 208, and they're telling you that this length right here is 192. That's not the full triangle. So you have to add them. You have to add the rest of it so that it can be 104 over 312. Does that make sense? No? Okay. So, what is 192 plus 96? Okay, so we have 288. That's the biggest, that's the whole side, over what? Over 96. Equals. Now we're trying to figure out the value of this, right? That's what we're solving for, that little x. So we're going to set that as the top, and that's going to go over our bottom, which is what? Corresponding side. What's the corresponding side to this? 40. Okay. So here we go. Cross multiply. 288 times 40 is what, Cooper? Cooper. What's 288 times 40? That's a big number. 11,000 what? Equals 96 times x. So then we're going to do what, class? Okay, so what's 11,520 divided by 96? X equals 120. So what is the distance across the lake? 120 feet. Was that as hard as you made it? No, okay, pick the next hardest one. Whichever one you want. Y'all decide as a class.
3.
3? 5. 5? Okay, so raise your hand for 3. Okay, read the words real quick. Go ahead and read through the problems. Hold on, no. Read through the problems and make sure that you want 5 or 3. I'm going to go between those two, 5 or 3. Okay. 3. Who wants me to do 3? Who wants me to do 3? Who wants me to do 3? Who wants me to do 5? Y'all are ridiculous. Okay, here we go. Number 5 wins. The picture at the left was taken of a crime suspect standing next to a counter at a local shop. The measurements shown are from the photo. The real counter is known to be 36 inches tall. How tall is the man? What do we do? .5 over 36? Why do you think 4.5 over 36?
Because 36 would be like the other triangle. It's not a triangle, but it would be like the other shape.
Other shape. So what kind of shape do you think we're looking at? My question is, it says, wait, my question is the real counter. So is the counter in this picture not real?
It's
It's not what? It's a scale factor? Okay, so What I want you to do is, I want you to just struggle for a second with your group. Struggle for a second with your group, and with your groups, and I want you to see if y'all can figure out how to set this one up. Ready, go. Okay, ready? So I basically did this. I put, real quick, hey. .5 over 9.5 equals x, 36 over x. So I put the scale drawing to the actual. That's what I did. So this is what's going to happen. 9.5 times 36 is what? $342 equals 4.5 times x. So you should get 76 inches. Is that right? Is that what you got?
How tall is EM2?
Divide that by 12.
So is he, alright, I thought it was
So 76 divided by 12. So 6.3. Look, so 6.3 feet, but look, 0.3 feet in inches. So what's 0.3 of 12? So he's like 6'3", 6'4" inches tall.
6.3, it's the closest to 6.3 and a half.
It kind of is. It kind of is close to 6.3 and a half. Okay, so ready? Here we go.
He's closest to
Your job is going to be to do numbers 1, 2, and 3. You may work on it as a group, and then I am going to give you your Mad Libs paper.